The 20th century was activated by oil and natural gas. And since the global demand and our dependence on fossil fuel proved to have changed the global environment to become more serious, consequential carbon gas trapped in the atmosphere caused the heat of the surface of the Earth to increase. Experts predicted that this greenhouse effect increased the temperature of the world. And for that purpose, protection on the Earth gave a new definition to the geothermal energy business. Indonesia is the largest archipelagic country in the world, with 17,508 islands spread between two continents, Asia and Australia. And there are more than 200 volcanoes, constituting an environmentally friendly, efficient and renewable geothermal energy source potential. Geothermal energy for electric generators was studied for the first time by New Zealand geologists, geophysicists, geochemists, and operated in 1954 as alternative energy. Indonesia's geothermal energy potential reaches 27,000 megawatts, including a high enthalpy of 20,000 megawatts. And this constitutes 40% of the world's largest geothermal reserve, consisting of proved reserves of 13,060 megawatts and resources of 14,080 megawatts. That amount spreads in Sumatra, reaching 13,820 megawatts, 9,253 megawatts in Java, 1,487 megawatts in Bali and Nusa Tenggara, 1,946 megawatts in Sulawesi, 534 megawatts in Maluku, and 50 megawatts in Irian and Kalimantan, respectively. It was this mud pond fluctuation, originally attracting geologists to their conviction that far below their feet there was a large geothermal source. Then, in 1976, Pertamina and a consortium of geologists from New Zealand constructed 3 exploration wells in Kamojang, West Java. It was this successful discovery that convinced us and the government of Indonesia to develop a clean, efficient, and renewable alternative energy source. Up to the present, Pertamina managed 15 working areas, where 7 of the working areas were managed by Pertamina alone and 3 of them had produced, i.e. those in Kamojang, West Java, Lahendong, North Sulawesi, and Sebayak, North Sumatra, while 8 other working areas were managed together with partners, among others, with Unocal Geothermal of Indonesia in Mount Salak, West Java, Amosis of Indonesia in Mount Derajat, West Java, PT Magma Nusantara Limited in Wayang Windu, West Java, PT Geodipa Energy in Patuha, West Java and in Dieng, Central Java, and Bali Energy Limited in the area of Batu Kahu and Bedugul, Bali. Hot magma penetrated igneous rocks of liquid magma congealment products having a high temperature in the Earth's deepest structure, and produced water and hot steam flowing to the surface through the fracture system occurring in the igneous rocks, and emerged as a geothermal manifestation in the surface or in the form of solfatara hot spring formulas and alteration rocks. The outgoing hot water directly sprouted upward, and there were those outflowing in the form of hot steam in a crack of rocks with a temperature ranging from 60 to 100 degrees Celsius. The geothermal extracted from a reservoir in the earth with a depth of about 2,500 meters had heat reaching more than 250 degrees Celsius. After vaporous hot water from the reservoir had flowed to the surface through a production well, the heat would decrease. To turn the geothermal electric generator turbine, the hot steam must be dry steam, and a separator for separating hot water from steam before entering into the generator turbine was needed. The first process, steam mixed with hot water outflowing from the production well, was collected to one manifold system, flowing through the main pipe and further flowing to the production separator, where in this separator the steam mixed with hot water was separated for the first time. To facilitate the standard meeting security operations, this was controlled in the control panel. After hot steam energy had been separated in the separator, it was then transferred to the scrubber to get hot steam or geothermal energy ready to turn the electric generator turbine. This geothermal dry steam was, after turning the turbine, condensed or cooled again in the condenser or in the cooling tower. Further, water in the condenser, which had had a temperature of 40 degrees Celsius, was pumped into the cooling pond to be re-injected into the geothermal reservoir as recharge. In principle, geothermal energy constituted an environmentally friendly and renewable natural resource, where the hot steam was extracted from the reservoir in the earth, and after utilization, it was returned to the well without creating significant pollution. The operation of utilizing geothermal energy into electricity continued to develop. The best Indonesian young women and men joined together in geothermal development. Its labor force was dynamic and had high motivation. By inviting geologists, engineers, and experienced managers to Indonesia, transfer of technology was one of the important strategies in human resource policies in this geothermal sector. Schools and education facilities built. Quality of roads improved. Social economy developed. All being the real shape of the geothermal project effort to always make a harmonious relationship with communities in the operation area which could not be reached by the government. This constituted the most important factor at this moment and continued to be developed by remaining to empower, dig and develop social economic potential so that local communities could improve their welfare independently and together with the geothermal operation area. The existence of alternative energy having high potential, such as renewable geothermal energy spreading throughout the archipelago, enables Indonesia to be able to economize on its gas and oil production as much as possible. With the evolution of present emission trade and environmentally clean development mechanisms, geothermal energy is given an attractive opportunity, having a positive impact on all of us, and with geothermal projects producing efficient and clean electric power, working to reach a brighter future for our children and grandchildren.